Okay, so this is a multimeter, and this is a battery. This battery, I've read it before, is 8 to 9 volts, which means it's starting to get flat, but it's not completely flat yet. So the idea here is I'm going to show you the voltage reading from the voltmeter of the battery when it is the terminal voltage, just as it is. That's going to be closer to the EMF than the second reading I'm going to take, which is when I short circuit using this piece of wire. I'm just going to short circuit the battery and measure the voltage. So the current will be as high as it can put out, which means the voltage drop across the internal resistance will be the maximum, which means the internal resistance is inside this, so we're going to be reading the remaining voltage across the wire, which should be much lower. So let's go ahead and do that. So first of all, let's get a reading of the voltage of the battery. Don't worry about the negative, it's just how, if it's there. So this is 8.85 volts. Okay, now watch what happens when I short circuit the battery. Okay, you can see that that voltage reading drops way down. It's flickering because I don't have a steady contact, but it drops way down. And then when I let go, you can see the voltage has dropped a little bit because I've flattened the battery even further, and the resistance of the wires and the multimeter is also causing a small current to flow through the circuit. So the idea there that we've seen is when you have a battery connected into a circuit, you get a better idea of the voltage it can actually put out. And so if you're measuring the voltage of a battery, there's not a lot of point in taking it out of the circuit and then measuring it, because it's not going to tell you if it's flat or not. But it's also a practical demonstration of internal resistance and EMF. So EMF reading is closer from a multimeter when you read it like this. When you short circuit it, you get the terminal voltage. Now I've just got an experiment here to try. This battery here is super dead. It's so dead that the resistance of the wires and the of the multimeter causes enough current to flow, or that it's got a huge voltage drop across the internal resistance, even just like this. And we got a very low reading. There we go. That's with no short circuiting. You can see it's going down as we read it there. So this one is very flat. There's an incredibly high internal resistance, and I'll just want to see what happens when we short circuit that one as well. I haven't tried this, but well, you can see that drops to nothing, absolutely nothing. So maximum current will be flowing, which is practically nothing, and the voltage drop across the internal resistance is so much higher compared to the voltage drop across this piece of wire. And when I take that off, look, you can see it's slowly coming back up, but even then it's still much lower than it was before. Okay, so for a typical battery, you'll be able to easily measure it in a circuit, and thank goodness for being able to measure voltage in parallel to do that. Otherwise you'd have to take it out of the circuit and cause a different reading. Yeah. So that's internal resistance and EMF.